discussing module 5 of the organic chemical technology course, and the module, as I told you, the module 5 that is having 2 lectures. One was the lecture 1 that was on the sugar and the alcohol production, and the second lecture will be, because I discuss also the importance of the ethanol, that is not only for the potable purpose, but the lot of the industrial application of the ethanol is there as a biofuel and the chemical feedstock. So we will be discussing in more detail about the use of ethanol as a biofuel and the chemical feedstock. This will be the coverage of the lecture: introduction, Indian alcohol industry, ethanol as a biofuel, potential for ethanol from cellulosic material. Already we discussed some part of this, and the biomass. So the biomass, how can we get the alcohol, gas oil, integration of the sugar, paper, distillery and a chemical plant. That will be in detail how the various useful material we are producing in the sugar and the distillery, which can be utilized for paper making, or that can be used for the manufacture of the large number of the chemicals. Although the chemical industry now uses raw materials based on, because you see the organic chemical industry, you take the organic chemical industry, we are produce whatever the chemicals now you are producing, 90% is from the petroleum route. So the all chemical industry now uses the raw material based on the petrochemical route. However, there has been always search for the renewable feedstock to meet the challenges emerging due to the shortage and rising cost and volatile market of the crude oil. Coal and ethanol has been used as an alternative feedstock from beginning of the 19th century, and again there had been interest in the coal and the ethanol as an alternative feedstock, because the ethanol that can be produced from the molasses or the biomass, and so the lot of the work that has, and all the multinationals and in other part of the world, they are more concentrated on the production of the ethanol and then the use of ethanol as a biofuel or as a chemical feedstock. Ethanol and biomass has again received considerable interest, as I told you, as an alternative source of energy and chemical feedstock. The development of the chemical industry from the alcochemistry technology has played important role in the supplementing the petro-based feedstock in sugar producing. Some of the constraints are there, because the cost of production that is high, cost of the molasses, volatile market of the molasses is also creating problem in our country, but in other part of the world, just like you take the case of the Brazil, they are going for the some of the polymer plant producing polyethylene based on the ethanol. So the alcohol is a key product for the manufacture of a large number of the basic chemicals. Alcohol based chemical industry occupies an important place in the Indian chemical industry and is a key contributor to the growth of the sector. However, as I told you, the highly volatile price of the molasses has been major concern in utilization of the alcohol from the molasses, because that is affecting the total cost economy of the process, because we are getting cheaper chemicals through the petrochemical route. But how long? How long we can depend upon them? Definitely we will have to go to see an alternative feedstock. The current size of the alcohol based chemical industry is around 1.1 billion, and that is 485 crores. There are 340 distilleries in the country with a capacity of 3500 million liters. However, the capacity utilization is low, mainly due to the non-availability of the sufficient molasses, because this is also one of the crises many of the alcohol plants they are facing, the availability of the molasses, because there is variation in the supply of the molasses, because that is, as I told you, the sugar cane production, that is also a seasonal, and even the sugar industry, they are not running continuously, they are for a particular season when the sugar cane is available. So in India, alcohol is mainly produced by the sugar and distillery industry as a byproduct of the molasses fermentation. As I told you, the technology for producing ethanol from cellulosic biomass through fermentation and chemical catalysis have been developed from lab to commercial scale. Already we discussed how we are making the ethanol from the biomass. Ethanol thus produced can be a promising chemical feedstock as well as source of the biofuel. This is the status of the alcohol industry in India, the production of the alcohol, and this is the application of the alcohol. Here the industrial use is that is 10%, 5%, 35% is the industrial application, 33% that is in the ethanol blended fuel, that is where the biofuel that is you are using, and 32% is the potable purpose. Globally, biofuels developments are primarily driven by the three fundamental policy considerations: rural development, energy independence, and reduced carbon footprint. Because the biofuel, you can use the 5 to 10% of the ethanol, because you see this is a oxygenate. Ethanol as a biofuel alcohol has been globally accepted as an alternative to gasoline, and alcohol blend gasoline are being used in many countries in varying proportion ranging from 5 to 20% as ethanol. India is now going an unprecedented energy crisis due to dwindling energy resources and the volatile market of the crude oil. The present import of the crude, which is around more than 190 million tons per annum, is expected to exceed 240 million tons per annum in the next 5 years. If the GDP growth of the around 6 to 7% were to be sustained. So the number of refineries, all the refineries, most of the refineries, they have increased their capacity. So even we are not able to meet the requirement. India is also importing 80 million tons per annum of the coal. Global crude oil prices are also surging unbeaten. Because why I am giving this figure of the coal, because still you will have to see the alternative sources. As a global crude oil is finite and depleting, there is continuously search for an alternative energy resources. All over the world people are working how to go for the, now they are going for the shale gas, they are going for the sand oil. All those things are only because just to utilize the whatever the resources that is available to make the fuel. So far the energy consumption is concerned, the world demand for the energy is expected to double by 2050, and this demand cannot be satisfied with the conventional fuel resources like crude oil, natural gas, coal. So we will have to think of the alternative source of energy, although the nuclear power plants are coming, but still the utilization of the whatever the nuclear power we are producing, it is much less. In order to meet the rising demand of energy and increasing population, because now we are having around 7 billion population. In India, we are having 1.2 billion population. So from where the resources will come? Alternative resources we are exploiting. The alternative energy resources play a growing role, and biofuels, mainly ethanol, are expected to grow fairly rapidly, reaching about 2% of the total liquid by 2030. Because ethanol, that is a source, that is a product we are getting from the molasses root from the sugar cane, and so that has become very important, especially the countries which are producing ethanol, sugar. Brazil, as I told you, is one of the major sugar producing industry. They introduced commercial gasoline with ethanol content of about 25%. Even ethanol is being sold in Brazil, pure ethanol, as E10, E100 fuel, means the 100% ethanol base. but that is separately. You will have to modify the engine also. Ethanol accounts for about 40% of the fuel consumed by passenger vehicles in Brazil. Brazil and US together account for about 70% of the world ethanol production. US, the largest user of the gasoline, and introduced gasoline with 10% ethanol content. Similarly, similar trend has been observed in the several other countries where the ethanol they are making from the molasses root. India has mandatory for 5% blending of the ethanol in petrol and is being implemented throughout the nation wide ethanol blending program EBP, which I show you the consumption 5%, that is through the nation wide ethanol blending program. About 3.5 billion liters of ethanol are being produced in about 320 distilleries in India, which is enough to cater to the 800 million liters requirement for 5% blending. That is constant because you cannot increase. Even if you are going beyond 10%, then definitely there are some other problems are also apart from the availability of the alcohol. So, however, the national average blending in 2008 to 9 was only about 2% because the rest of the alcohol that was being utilized for other purposes. So, that is very important if you are going to use ethanol as a biofuel. So, the availability of the ethanol at the cheaper because the cost of the ethanol that is definitely slightly higher, and if you are blending then that may increase the cost. That is one term you are using the gasol. Gasol is the new eco-friendly fuel containing blend of gasoline with 5 to 10% ethanol from molasses. Gasol can be also made by blending gasoline and methanol because another product that is very important, that is methanol, that is also oxygenate, but there was some problem in the initial stages when the MTV won a product that you are getting from methanol. I will be telling something about the various oxygenates that we are using. And so, the gasol has higher octane or energy knock property than the gasoline and burns more slowly, coolly, and the completely resulting in the reduced emission. So, that is the advantage in many of the oxygenates we are using. The octane number of the gasoline increases with the blending of 5% ethanol by 1.3 to 3.4 times. Blending of ethanol increases the reed vapor pressure and vapor lock index. Ethanol increases the oxygen content of the blend because different oxygenates which you are using, it may be ethanol, it may be methanol, various ethers are there. So, oxygen content that is varying. This is some of the oxygenates, their boiling point, blending point, average octane, oxygen contains and blending limit that is reported. MTB, ETB, that is methyl tertiary ether, ethyl tertiary butyl ether, and the TAME, because these two products MTB and TAME that is being made by using the C4, C5 gases from the FCC. So, that is one of the major source of the MTB and TAME, but as I told you, the ethanol, blending of the ethanol and the replacement of the MTB, that was not well taken, because in case of the MTB it was reported that MTB is highly corrosive from the carcinogenic, and so there was problem in the US, so they banned the use of the MTB. In case of the MTB, huge amount of the methanol that we are using. So far the TAME is concerned, in Jamnagar refinery we are making the TAME. MTB that is being made by the Indian Oil Corporation Vadodara unit. These are the two important, actually the oxygenate, boiling point and other details are given here. Alcohols, amongst the alcohols methanol and ethanol, that can be blended, methanol that can be blended, but here if you see the temperature, boiling point, and there is difference in the average octane number, methanol that is superior to ethanol, but again because normally whatever the methanol we are producing that is through the synthesis gas route. But as I told you while discussing the raw material, in the future lot of the work that is from the coal to methanol or the biomass to methanol, some plants are also coming, and so they definitely the methanol that will be more cost saving or the alternative source that may be there, and this is about the ethanol and blend of GTP. So, this is the various type of the oxygenate, these are called the oxygenate. So, oxygen definitely has some of the property better than the other, but not if you compare with the ethanol, definitely the average octane number, that is the research octane number and the motor octane number. So, average that is higher in case of the methanol. Now, let us discuss, that was about the one of the problem that we are facing in utilization of the ethanol, that is the availability of the ethanol, because the other uses of the ethanol, the products which we are getting especially for the potable purpose are as a chemical feedstock, definitely that is more economical, and the economic part that is playing important role, and the major concern, and the at the same time availability of the continuous availability of the alcohol for the gasoline blending, in the blending of the alcohol with the gasoline EBP. So, that is the actually the problem in case of the ethanol. But ethanol as a chemical feedstock, let us discuss in slightly more detail. I already told you in the lecture 1 about the importance of the ethanol in the chemical industry. Chemical industry utilizes a wide variety of the raw materials like petroleum products derived from crude oil and natural gas, ethanol, coke oven, byproducts like coal tar and other inorganic constituent through the calcium carbide. These were the some of the actually the raw material which is available, and as I told you the 90% of the total chemical organic chemical that we are producing through the petroleum route. Only the because the coke oven plant, that is byproducts so utilizing. So, only the smaller portion of the total requirement that of the feedstock for the organic chemical industry is through the coke oven plant. Ethanol has played important role during the developing stage of the petrochemical industry by providing feedstock for manufacture of large number of the organic chemical which is now being produced by petroleum route. Because you see the during the 1950s, so far India is concerned, we got the independence in 1946, and the period 1947 to 1960, that was the era of the industrialization. Even we are not having any petrochemical complexes. So, at that time the source of the some of the raw material for chemical industry, that was the ethanol, because the sugar industry is very old in India, and so even the fermentation industry, production of the alcohol, that was starting long back before coming of the petrochemical industry. So, the ethanol that was considered as a promising feedstock for making a large number of the petrochemical. Even if you see the some of the your chemical plant based on totally ethanol, that was started one of the plant, that is the at Risra by ISI with a very small capacity plant they started, that was for the production of ethylene from ethanol. Similarly, synthetic chemicals and barely they started making SBR, styrene butadiene rubber, they are using the ethylene produced from the ethanol, and the Indian glycol and jubilant organisms which I told you, they are the two major Indian glycol and the jubilant organisms, and the Somaiya chemical was also there, but now they have stopped their plant at Barabanki. So, the as I told you in the lecture 1, that India is among the top sugar producing country in the world and produces ethanol from the byproduct of the molasses. With the rapid growth of the sugar industry, more molasses based alcohol plant has been set up and are providing the feedstock for number of the chemical industry. Between 1960s and 80s, numerous alcohol-based plants came in different part of the country manufacturing the organic chemicals like ethanol, ethylene, ethylene oxide, MEG, DEG, TEG, acetaldehyde, acetic acid, acetic anhydride, butanol, ethoxylate, pyridine, picoline, butadiene, synthetic rubber, polymers like polyethylene, PVC. Because the in case of the PVC or polyethylene, we are using the ethylene, and that ethylene can be made available from the ethanol. So, I told you that some of the major players which are using the alcohol as a raw material, that the Indian glycol, where they are making ethanol, ethylene, ethylene oxide, MEG, TG, and DEG, TG, monoethylene glycol, MEG, and so they are also making the ethoxylate. VAM organic, now jubilant organics, they are making a large number. That is one of the, actually you can say, large integrated chemical complex totally based on the molasses. They are having the alcohol plant where they are producing the alcohol, and that alcohol they are using for the production of ethylene, and from the ethylene a large number of the chemicals they are producing. Somaya chemicals, again that was in Barabanki, so they were producing, and apart from there are other number of the chemical factories are using the alcohol based ethylene, just like synthetic chemicals and rubber barely. Now it is closed. Earlier it was making the, that was the first plant based on the molasses root for making of the synthetic rubber in India. SD chemicals, Canoria chemicals, and large number of plants based on the ethanol were started during the that period when the number of the sugar plant increased. India first started ethylene through ethanol route by ICI in Risra, West Bengal. Bioethanol based plants has been also started in other part of the world. In Brazil, ethylene derived from ethanol is being used for the production of the polyethylene, totally based on the molasses route or the alcohol from the molasses. Major routes for ethanol as a chemical feedstock, because ethanol to ethylene, because how we are making, what are the product that you can, a long list of the chemicals are there which we are making. First major product we started in case of this Indian glycol or VAM organic, that was the conversion of ethanol to ethylene, because vice versa you can produce ethylene to ethanol also, that is through the petrochemical route, but most of the ethyl now because large capacity naphtha cracker has come and we are producing lot of ethylene from the cracker plant, but earlier route was before coming of the cracker, that was the ethanol route. So, ethanol to ethylene, ethanol to acetaldehyde by partial oxidation or the dehydrogenation, this was the process of making, and the VAM organic they are making the acetaldehyde from this route, acetaldehyde by liquid phase oxidation of ethylene, acetic acid by liquid phase oxidation of ethanol, acetic anhydride from the acetaldehyde route, and this acetaldehyde again from the ethanol produced from the molasses. 1-butanol from condensation of acetaldehyde, again acetaldehyde the same route, ethanol to ethylene and ethylene glycols, MEG, DEG, TEG, glycol ethers, ethoxylate. Ethylene from ethanol to ethyl benzene and then converted to styrene. This was how the ethylene that was used in synthetic and chemical barely for producing the SPR. Vinyl acetate from the ethylene and acetic acid by vapor phase process, ethanol to butadiene, vinyl acetate from acetic anhydride and acetaldehyde, vinyl chloride from ethylene, ethylene again from the alcohol route, because now all the vinyl chloride except one plant at Siram Chemicals which they are making the vinyl chloride from calcium carbide route, all the plants are based on the ethylene from the cracker, but that can be a source for the making of the vinyl chloride. only constant that is the cost of production of the ethylene which you are getting from the alcohol route, that is higher than the what we are getting from the cracker plant. Then the other important product that can be made acrylic acid by carbonylation of the ethylene and the acrylic acid to acrylate by esterification. Ethyl acrylate from ethylene oxide through cyanohydrin route, acrylonitrile from, because acrylonitrile again that is one of the very important product for making of the acrylic fiber which we are making through the petrochemical route from the propylene, but that route is available. This is the beauty of the nature. They have provided a large number of the alternative raw material resources for us, and only thing that how best we are utilizing. So, acrylonitrile from dehydration of the cyanohydrin made from the UO and the hydrocyanide. This is the product profile of ethanol and how they, you see the some of the plants they are making, just like I told you, the jubilant organics, or it maybe it was the Somaiya organics, or even in case of the Indian glycol. This is the molasses. After the fermentation you are getting the ethanol. This ethanol that will be converted to acetone, and that is being used. Large application of the acetone is there. Ethyl alcohol that is converted to butadiene, which is being used for the making of the, and this was the actually how the styrene butadiene rubber plant that was started at Bareilly. Then ethyl alcohol to ethanol. As I told you, both the routes are there. You can produce ethyl alcohol to ethanol or ethylene to ethanol. So, the route is available only if you are coming from ethylene to ethyl alcohol, then that will have to go for the petrochemical. So, ethylene, this ethylene that can be a large number of the product which you are getting, which you are making from the ethylene through the petrochemical route. And this already I discussed some of the products which you are getting from the ethylene. And one of the very important product from the ethylene, that is the ethylene oxide or the ethylene glycol. Ethylene glycol means both the mono, di and triethylene glycol, and these products are finding wide application in case of the antifreeze, alkyd resins, or when the polyester MEG. MEG, huge amount of the MEG that is being used in the manufacture of the polyester during the polymerization reaction of the terephthalic acid, ethylene glycol we are producing. So, ethylene oxide, that is one of the very important product. Then the another product which we are getting acetic acid, and that acetic acid again that can be used for making of the number of the products also. Then the butyldehyde, from the acetaldehyde that you can make, and then that will be ethyl 2-ethyl oxide alcohol that may be there. So, which is being used in case of the plasticizer. So, this is the actually the ethanol tree, you can say, from where you are making a large number of the your chemical, which are now most of the cases now the what you are doing, you are having the ethylene, and from ethylene all these products that can be made. This is the process that is being used in case of the when you are, because you need the oxygen for oxidation of the ethylene, and here actually it is shown that the sugar plant, molasses, fermentation, biogas plant, because the spent waste which you are getting, that is going to the biogas plant where you are generating the biogas, and again that is being used in the plant, and the alcohol, ethanol dehydration, then ethylene, and then the ethylene, by oxidation of ethylene you are getting large number of the product, starting from ethylene oxide, ethylene glycol, MEG, DG, TG, which I told you that you are getting, because during the hydrolysis of the ethylene oxide all the MEG, DG or TG are formed, and so that can be actually, you can control the formation of the your this MEG with the controlling the water during the hydrolysis. These are the some of the products, alcochemical products which we are getting and their application styrene and styrene, ABS resin, sand, ion exchange resins, LDP, ethylene that you can use, and these are the major application downstream application of this valuable product. It may be ethylene, because styrene what we need the ethyl benzene, and for the ethyl benzene what we need benzene and ethylene. So styrene can be also made through this route using the ethylene from the, this is what the synthetic and chemical Bareilly plants they are using. Another already I discussed the MEG, vinyl acetate, these are the application of the various product that we are getting from the, because the VAM organic, why the name came, the vinyl acetate monomer, that was being, so they kept the name the vinyl acetate for making the polyvinyl acetate. So that was the major product of the jubilant organisms. So these are the some of the application, SBR, acetic anhydride, when you are making the cellulosic synthetic fiber, cellulose estate they are using the acetic anhydride. Other application are also there. Then the again styrene, acetic acid, acetic anhydride, various products we are getting from this, and so they are finding use for the solvent for acrylic fiber. Dimethyl acetamide, actually now we are making the dimethyl formamide, dimethyl acetamide through the synthesis gas route, but from the acetic acid also we can make the dimethyl acetamide. Then the acetaldehyde, again acetaldehyde, pentathiol that we are using in the paint industry, and this is also used in the explosive. PETN, that is the explosive industry which I tell you, because there this is the through the ethylene oxide route. Glycol, the pharmaceutical industry. Then the other product, large number of the products are there where we are using in some or other form the ethanol, ethylene and their derivatives. So chloroacetic, MEG, that I told you that is being used for the polyester, acetaldehyde, etc. Now let us discuss one of the very important part in case of the, to improve the economy of a sugar mill. We can integrate the sugar, paper, distillery and a chemical plant, and definitely that is going to improve the overall economy of the sugar plant. But only thing that the location, because earlier some mills are not having the distillery, paper mill are other side, so normally they are transporting the bagasse from the sugar mill to other places where they are making the paper. Similarly, the molasses that being transferred from the sugar mill to the some of the distillery where they are producing. So these are the some of the actually the, but definitely the some of the product which we discuss either as a biofuel or making a large number of the chemicals, or the bagasse as a paper, the raw material for paper making. While discussing the paper making, we discuss so the 100% bagasse based plants are there which are using the bagasse, because the quality of the bagasse fiber is much better than the wheat star and the rice star. So this is the how the integration, modification and anticipation could revitalize these interdependent industry. Integration of the sugar, distillery and paper manufacturing, chemical manufacture and waste utilization will help in generation of the revenue and will make these industry more attractive. And so in the next slide I will show the how the sugar plant that can be integrated, because now we are some of the mills they are having the integrated from starting from the molasses. Some of the units they are having this small paper mills integrated with the sugar plant, and some of the mills only they are having, they are using the bagasse and making the paper. So they are scattered, not integrated, but there is a scope of integration, because now we are talking about the integration of the petroleum refining in the petrochemical. In the same way we can integrate the sugar plant, paper plant and the distillery. So this is the how the we can integrate the sugar cane manufacture, then the sugar to sugar plant bagasse, it will go to bagasse cellulose pulp, and that will go to the newsprint, that we can make the that cellulose that can be also used for the rayon manufacture, and then the bagasse that can be also a source of energy in the bagasse fire boiler, bagasse flash that can be used adsorbent, ceramic filter, fire briquettes that can be used, and then the here other sugar that will go to the, we have already discussed press mud which you are getting during the clarification of the your juice, so that will go for the composting. Similarly, the molasses that will go to the distillery plant, from the distillery plant that will go to the spent wash will be getting, and this spent wash we are making the alcohol, and then the spent wash that will go for the anaerobic digestion, and the again for the further treatment that will go the RO system, and the residue after separating, after treating the effluent from the anaerobic digestion, that can be used along with the press mud. This is what some of the mills they have already started composting the press mud with the residue from the RO. Then alcohol that will go to the breweries, that will go to the biofuel building, that will go for making of the industrial alcohol, that will, and which can be used the chemical feedstock, which already we discussed in detail about the what are the chemicals that can be derived from the large number of the chemicals. Many of the chemicals which now we are making from the petrochemical route, that can be, and that was made earlier before coming of the naphtha cracker or the gas cracker plant, when the availability of the ethylene that was less, and so that was being produced through the ethanol route. So this was about the integration of the sugar plant with the paper mill or the chemical. So just to conclude about the role of the sugar industry and the alcohol industry in the chemical, that can be vital. You see, it is not only the sugar for edible, for you are taking the only the purpose of, we are also manufacturing a large number of the other products, that is the alcohol, very important product. We are generating the bagasse, that can be a very important source for the paper making, that can be source of some of the chemicals also, that can be a source of alcohol also, and the alcohol which you are making, that is not only the for the potable purpose, but that will be a major source of the your chemical feedstock through the ethanol to various chemicals, or ethanol to ethylene, and from ethylene to for making of this. So the future of the sugar industry, only the problem constant which is there in utilization of the ethanol based ethylene or the ethanol as a chemical feedstock, is the cost of production of the alcohol, cost of production of the ethylene, and the varying the volatile market of the molasses, and which is not also the continuous supply of the molasses. So these are the things, but still in the future, when there is a shortage of the raw material, we can utilize these various byproducts from the sugar and distillery as a source of the energy, as a source of the chemical, and for other purposes as a biofertilizer.